Hello class, this is our lesson for section 2.3, introducing polynomials. These are our Algebra 2 notes. So a polynomial function of x is a function given by a sum of terms. So a bunch of terms with plus and minus signs or plus and negative, each of which is a constant times a whole number degree of x. So the degrees have to be whole numbers. Polynomials are often classified by the term with the highest exponent. Oops, sorry about that. Once in a while I do that stuff. And in standard form, it lists the terms in descending exponent order. So we've got a couple examples here. Our first example, g of t is 10 plus 96t minus 16t squared. So we want to, I would first rewrite this in standard form. I would do this part first. So standard form means I want to write it in descending order. So I'm going to write the squared term first. Because it has a minus in front of it, I'm going to write it as a negative 16t squared. The next one would be t to the first power, so the one that has a t by itself, the plus 96t. The t doesn't have an exponent, so we know it's first power. And then the last thing I would write is my constant term, so plus 10. So my powers for t go 2, 1, and then 0, because there's no t at all. So now that I have it in standard form, I can see that my leading term is the negative 16t squared. I can see my leading coefficient is a negative 16. I can see that my degree is 2. On the next one, it looks like it's already in descending order. I've got x to the first power and then no x at all. So right away my degree is going to be 1. My leading term is 3x. My leading coefficient is 3. So remember, coefficient is just that number part, like the constant that's being multiplied by the x. So examples of non-polynomials would be like if I have a negative exponent. So 3x to the negative 2 power plus 4x. That would be not a polynomial. It has a negative exponent. Variable or decimal exponents. So if I have a 5x to the 1.5 power plus 3, that would not be a polynomial. If the variable is the exponent, so if I have like 3 to the x power plus 2x squared, that is not a polynomial. My x is in the exponent. Roots are bad. So if I had like 2 times the square root of x plus 3x, that would not be a polynomial because of the square root. Variable in the denominator. So it would be like a 3 with an x in the denominator. That would be bad. So let's kind of go through and just highlight all these. Like this one's a problem here. The 1.5 power is a problem. The x as an exponent's a problem. The square root's the problem. And x in the denominator is a problem. So we've got a lot of different things that we can't have that make it polynomials. Polynomials are really easy to work with. They're functions for the most part. We like them. They're easy to work with. So here are 3 different graphs of different polynomials with degrees 1, 3, and 6 respectively. Label the relative maximums and relative minimums for each graph. So if I have a straight line, it's going on forever in both directions. I have no relative max or relative min. On the next one, this right here is going to be a relative max. That's because that point is higher than all of the points around it on both sides. So that's going to be a relative max. And we're just putting them on a graph right now. We're not worried a whole lot about them. It looks like a relative max of maybe about 20, right? Something a little bit less than that. Here I've got a relative min. And my minimum. So when we talk about maxes and mins, we're talking about the y values, right? I have a maximum of 20. I've got a minimum of 0. On the last graph, this is going to be a relative minimum right here. So we're really looking like at these humps, right? The humps, because it's the points around it are all going to be lower or higher. This is going to be a relative max right here. I know this point looks interesting to you, but these points over here are bigger and these points over here are smaller. So it's not a max or a min, but it is a point where the graph is changing shape, and we'll talk more about those later. This is going to be my relative min. I don't know why I put mix there instead of min. I don't know what I'm doing. All right. This looks good. Okay, types of polynomials. So if we have something that's 0 power, that means we have a constant. So that would mean, remember, if we talk about x being to the 0 power, that's just 1. It means there's no x at all. So that's going to be like y equals 2, right? There's no x with the 2. And I'm just going to do a quick graph example. Like there's my x and y axes. So my graph of y equals 2 would be something like that. On the next one, if I have first degree, that's linear. And it would be something like y equals x plus 1. So here's my graph. So y equals x plus 1 would cross at 1 and be something like that. And next we've got quadratic. So quadratic is something like y equals x squared plus 2x plus 1. And that would be some kind of, quadratics are like a U shape. Oop, let me pick a different color for the actual graph. So something like that. I meant to have that touch my x-axis, but it did not quite. That's okay. I'm going to fix it. It was kind of an ugly quadratic. So we know it's a U shape. That one's a little bit better. Third degree is going to be cubic. So I'm going to write an equation with y to the third power, or sorry, x to the third power. So like x cubed plus, 4x squared plus x plus 1. Cubics in general are going to be, so look at what we've got here, right? We got a straight line that's just horizontal. We've got a straight line that's vertical. Now we've got a turn. So cubic is going to look like this, possibly. They don't all have to look like that. But notice now it's like I had no humps. Now I've got one hump, and now I've got two of these like little humpy things on my graph. When I look at fourth degree, that's quartic. And quartic could be like, x to the fourth plus, we're just making a random one, not the one I'm graphing. 3x cubed plus 2x squared plus 5. You don't have to have all the terms, but the biggest one has to be fourth degree. And so when I go to graph a quartic, that can now be something more like this, where I've got 1, 2, 3, right? 1, 2, 3 turning points. So I've got 0 turns here. I've got 1 turn here, like 1 hump means 1 turn in direction. I've got 2 turns here, and I've got 3 turns on this last one. So the number of terms, a graph of a polynomial will have no more than 1 fewer turn than the degree. And this sounds really confusing to me. So if your degree is x, it would have x minus 1 turns. So if your degree is n, then no more than n minus 1 turns. I'm sorry, my family is super loud in the background today. I don't know what their problem is, but we're close to being done. So last two, check your understanding, determine if the expression is a polynomial. If so, rewrite in standard form, state the degree, type, and leading coefficient. So is it a polynomial? Yes. All of my exponents look good, no negatives. I don't have anything in the denominator, I don't have a square root. So yes, it's going to be a polynomial. So now to answer my other questions, I want to write it in descending order. So I'm going to write the x to the fourth power first, then 2x cubed, and then a 3x, and then a minus 2. So now my powers are going down. And it's okay that I don't have a squared term. That's fine. So my degree is the highest power of any of the terms. So the degree is 4. My type, well, if it's degree 4, it's going to be quartic. After 4, generally people would just say like 5th degree, 6th degree, and not worry about naming them. You really could say this was a 4th degree polynomial. That would be okay, but we do have a special name for it. And my leading coefficient is going to be 1. So remember that x to the fourth, there's that imaginary 1 in front of it. Okay, second one, let's see. I've got 4x squared plus x to the negative, negative exponent. So nope, it's not a polynomial. So can't do anything with that. So this is just some vocabulary, basic graph behavior, not anything super new, but it is vocab to memorize. So as always, if you need help, please make sure you ask.